In this video, we will be looking at the rational root theorem. For the polynomial p of x, which equals alpha times x to the power of n, plus a series of polynomial terms plus the constant beta, where alpha is the coefficient to the leading term and beta is the constant term, possible rational factors are given by. So what we do is we take the positive and negative case of the factors of the beta term, which is the constant term, divided by the factors of the alpha term, which is the coefficient of the leading term. Once we've identified possible rational factors, we can find rational factors, so the actual factors, using the factor and remainder theorem. And that theorem states that if the polynomial evaluated at negative b divided by a is equal to 0, then ax plus b is a factor of p of x. So we want to consider the polynomial p of x equals 2x to the power of 3 minus 5x squared minus x plus 6, and we want to use the rational root theorem to find one rational linear factor of p of x. So the leading term is this x to the power of 3 because it has the highest power, so the 2 is important when we use the rational root theorem. Similarly, the constant term, which is plus 6, is also important when we're using the rational root theorem. So the rational root theorem states that possible factors are given by plus or minus the factors of 6 divided by the factors of 2, where the 6 is the constant term in the polynomial and the 2 was the coefficient of the leading term. So this is equal to plus or minus, the factors of 6 are 1, 2, 3 and 6, divided by the factors of 2, which are 1 and 2. So with this information, we can state all of the possible factors as a combination of the numerator and the denominator. So we're going to have plus or minus, and 1 divided by 1 gives 1, and then negative 1. And then we have 2 divided by 1, which will give 2 and negative 2. 3 divided by 1, which will give 3 and negative 3. And 6 divided by 1, which will give 6 and negative 6 when we take the positive and negative cases. So they are the integer values of the rational root theorem. And now we're going to look at non-integer values. So we can have 1 divided by 2 gives a half and negative a half. 2 divided by 2 would just give 1. So the next one is 3 divided by 2. So we have 3 divided by 2 and negative 3 divided by 2. And then if we have 6 divided by 2, that just gives 3. And we've already stated 3 and negative 3 earlier in this list. So the next thing we need to do is we need to test out each of these to see which ones are factors. So we're going to start by ignoring the integer values 1, 2, 3 and 6. And we're trying to identify a fraction linear factor for p of x. So we're going to start by testing p of 1/2. So if we do that, we have 2 times 1/2 cubed minus 5 times 1/2 squared minus 1/2 plus 6. And now if you evaluate that, you'd find that that's equal to 2 divided by 8 minus 5 divided by 8 minus a half plus 6, and when you evaluate that, you find that it's equal to 5. So because it's not equal to 0, it is not a factor of p of x. So next we're going to test p of negative 1 divided by 2. So we sub negative a half in and we have 2 times negative 1 over 2 cubed minus 5 times negative 1 over 2 squared minus negative 1 over 2 plus 6. And that is equal to 9 divided by 2, so it is also not a linear factor. And then we go on to 3 divided by 2, so we're going to test p of 3 divided by 2, and that is going to equal 2 times 3 divided by 2 cubed minus 5 times 3 divided by 2 squared minus 3 divided by 2 plus 6, and if you evaluate that, that is equal to 0. So now that we know that p of 3 divided by 2 is equal to 0, we know that 2x minus 3 is a linear factor of p of x. And we reach that conclusion using the factor and remainder theorem, which was on the previous slide. So after this video, you should be able to identify possible rational factors using the rational root theorem, and be able to determine the actual rational factors, if they exist, using the factor and remainder theorem.